from someone who lived in Seattle, got the same problems. We're going to go back a little bit into the machine learning side of the world, and wanted to introduce Susanne. And you can see her great bio up here, but I think the thing to ask her during cocktail hour is, what's her favorite socks? Over to you. I'll give you a clue, she's wearing it.
Perfect. As you can see, I'm wearing the InfluxDays. It's the only reason why I came here. They are getting a hole here, and I needed a new pair. So, well, no. I'm going to talk about the SciPy stack and compare it a bit to InfluxDB and Grafana. Why so? I come from the biomedical world. I'm a physicist, and I've been working in neuroimaging for quite a bit. And at a certain point, I got a bit bored, because in those studies, often you do not have enough data. You cannot scan enough subjects, and you need to infer from too few data. For this reason, then I started looking out for a company that had lots of data. And this is basically when I found Würth. Würth is an IT and consulting company of the Würth group. I think, given that we have a male audience, Würth is something that almost everybody has seen at least once. And we're headquartered in Italy. That is where I'm living now for about 12 years. And most of you only know it for skiing and holiday, but we also make software there. Yeah, we have lots of international experience in business software and IT management. Our core competencies are trading processes, wholesale distribution, and logistics. We're also Microsoft Gold certified partner, ITOA certified, or TRS preferred partner. But let's say what we really want to do is we want to improve the business productivity by delivering world-class software solutions with a team of highly motivated and skilled IT experts. I also brought 2 of my colleagues, so if you want to really know about who is then getting data into Influx, modeling with data, you can also refer to them. I will let you later. Basically, there I was satisfied. There was data, no stop to data, and they knew about databases. So everything that I could not dig in the medical world, I can now, because I also have a machine learning background, and let's say many of the techniques could be transferred one-to-one to this new field of application. And even if the talk is called SciPy stack versus InfluxDB and Grafana, we are doing kind of a way back in time, and we start here. Like 2 or 3 years ago, the demand for application performance monitoring of business critical applications was growing a lot. What should you imagine under that? As part of Würth Group, we have many customers that have one application. If that application does not work, they simply cannot go on, maybe with a work chain, or maybe they cannot do invoices. They lose a lot of money. So they need to be really sure that it's working now correctly and also working in the future. So if you look at this slide, the problem in our days is that the complexity has really increased. Like, to monitor whether one application is working, it's not enough to monitor a tiny part, like the application, but you need to know, is the cloud services that maybe it's communicating to or based on working at the moment? Is the application server at the moment at a state that is okay? Can I communicate with my customers? Like, if my program is working fine, but the mails are not sent or I do not get feedback, maybe I can still not work as I should. Then we know about virtualization. So even this might influence and impact my quality. So performance gets something that is far more complex than 10 or 20 years ago. Because I have my data center, I have the internet, I have a home network, a company LAN, a mixture of all of them. And the problem is that I want to see everything. I want to get the whole picture. And as many of you might know, it's not very easy to get this complete picture. But we have a few human experts, and they have been doing nothing else almost for the last 20 years than controlling whether one certain program that they know very good, an application, it's called Microsoft Dynamics AX, is working fine. So in these 20 years, they really collected lots of expertise, lots of domain knowledge, and yeah, it's really difficult to replace that because those have really seen over the years if that happens together, most probably now if we take this counteraction, then everything is going to work well again. But it's their decision, and it's very hard to put that into data or to put that into an algorithm that then is intelligent enough to help them or even sometimes for smaller tasks to substitute them. And how do they do their analysis? Usually they have a lot of tools. Like over the years, they found out I need to have a look at these metrics and I can see them if I use this tool that is given from this vendor. Then I need this different tool and I can only see another tiny part of the metrics. And then maybe they have a homemade script for just a few other metrics and a different tool still for this certain customer that together with the application that he's monitoring needs also this kind of information. Well, we see the problem. As long as one or more experts are following one customer, no problem at all. But when your company is working well, if you have more than one customer and more than one customer is complaining or have problems, then you would need more experts. But you cannot duplicate them. Like their experience is really difficult to split and their expertise also. So it's not talking to the HR department and saying, we need another human expert, because this other human expert would need years, or at least months, to be a real help to this person that has been in there for 20 years. So what can we do? Basically, we started analyzing what these human experts were doing, how were they spending their time. Then we were thinking about how can we optimize the time and which part of the work that they are currently doing can be maybe automated or at least supported. So the main goal is still that the application that is business critical for the customer should always run and always run perfectly also in the future. So when thinking about a problem, the human expert will try to figure out what kind of problem, what type of problem it is. And usually it's not that a ticket will come in and he will directly know, okay, it's related to that. But he will, let's say, have an idea what could be, but not already the solution at hand. Then, let's say, as soon as I have an open ticket, it's already late because the problem is already there. But obviously, the expert wants to know when did it start and till when did it last? Or is it still ongoing or has it already partly resolved on its own? The location, is it something that only is located on one server, or is it something that maybe is on many tiny parts of my system, and what's the impact? Like, if I know I have a problem there, where will I have problems tomorrow? Once he has understood these first 4 parts, obviously he will think about a solution to that specific problem, try it, then he needs some kind of feedback. Have I solved it? And nothing is better than data, because if they do not call anymore, maybe they are simply so frustrated that they do not tell us that it's even getting worse. But via metrics, we can see whether my counteraction had an effect. And the last part is prevention. Obviously, when I found out there has been this problem, I want to avoid that in the future, so I do not have it anymore. This was the point when I, as a very fresh newbie in the company, was meeting one of these experts. And he was telling me, yeah, most of the time, basically, I am there and I'm actually going through these different tools and trying to find the right metrics, trying to find the right scaling interval. Once I have found something there, then I need to adapt all the other tools to the same interval, and that's really hard. Sometimes maybe I cannot open enough tabs that I print something and put it in front of me, and I was seeing him like with weeks of curves, and it seemed a bit strange for me coming from another world. But I knew he had the expertise, he got the problems of the customers solved, so I needed to support him. What I knew very well was the SciPy stack. So NumPy for mathematical operations, matplotlib for plotting, Seaborn for making plots a bit more handsome, Pandas for data science and data manipulation, and scikit-learn for machine learning. So basically at that stage, I, together with another colleague, took them and we tried whether we could do part of the analysis that he was doing, like preparing data for him, essentially. So when he knew in that week he had a problem, then instead of making him lose time in scaling, zooming, and so on, we simply delivered all the metrics from different data sources via a really huge sheet, so he could print that. Seems really not the thing to do in 2015 or 16, but this is how it basically worked. And then it came to his mind, yeah, what I do next is usually I go back in time and see whether a week before now it was the same or whether something has changed. Okay, then we simply plot last week's curve together. Yeah, that would be helpful. So we prepared kind of reports that had 2 or more curves depending on last week, last month. And I was like, okay, I went to that company because I wanted to see something about databases. And now I'm doing imports, exports, CSV files, access to tools. Doesn't seem the thing that I originally wanted to do. Yeah, but then I couldn't go on because there was already the next request. You know machine learning, now try whether you can do some kind of anomaly detection or machine learning to support this human expert. And in your nice graphs that you're doing, couldn't you highlight a few parts that look from a mathematical point of view significant, interesting, that maybe are those that he's looking for, he only has not yet seen them? So when I think about machine learning, and in this case, anomaly detection, as we have heard, we have this really nice preparation. He has left now, fortunately. I start at the metrics, like we have lots of data. The more we have, the better. Then we split it into train data and test data. And the train data usually is used to build a model. What do we model? We model standard behavior. On what is it based? Usually on historical data of the same metric, historical data of similar metrics, historical data of similar machines. And then, what is this kind of model? It's what we do expect. Like, it's an answer to what could my data look like, what would be standard. And then, when I do testing, what do I basically do? We have already heard it. We see how far am I away from my expectation. If I'm far away, then maybe my model was not good, or if the model was good, then I'm actually encountering a state now that data is really different. And the interesting thing about machine learning is it's not a processor curve always around 30% and then a 70% peak. It's not only that it detects, but it's actually multivariate, multidimensional. So I can have a look at many, many curves together. As we saw in an earlier talk, the human eye is able to see about 3 curves at a time, maybe 10 if it's a really good human expert. But when it comes to 100 curves, I'm sure they will not realize anymore. And it's also not that something that is detected as an anomaly is necessarily something wrong or bad. It's just something rare or something strange. Like only a label or experience then could also give the character to the anomaly. But at the moment when it's detected as something that cannot be explained from the past data or from our standard behavior, then it's something rare or something strange, but it could also be an improvement, mathematically speaking. And now, coming back to our many curves, simply take 3 of them. In the past, often you analyze them one by one, meaning processor looking fine, memory looking fine, batch tasks looking not fine, okay, okay, not fine. How do I bring them together? And multivariate analysis is exactly the opposite of that. There I am looking at states. So if this curve is behaving like that, and that in this way, and this in that way, this together is some kind of state. 5 minutes after, I will have another state, and so on. And what I'm learning as my standard behavior is not the standard behavior for one curve, but a kind of a standard state. So it is probable that all the curves behave together in that way. And when I'm far from that, it might be that a single curve is far away, but it might also be that more than one curves are a bit away, and not that much, but they are also relevant. So this is how far are we from expectation. Seeing not a single curve at a time, but many together, and highlighting such areas. Then, after having implemented these markers, it was finally possible to think about making this all dynamic and navigable and trying InfluxDB. You see it from the logo, it's the old one, it was 2016, when we then moved from offline and scikit and so on into something a bit more in a direction that felt familiar, that felt good, InfluxDB. Everything was inside a single data source. Obviously, it took us a bit of time getting data there. At the beginning, we did not use Grafana immediately because all the algorithms were already done in the Python. So we could basically now, instead of importing many files from many sources, simply always address InfluxDB and get the same graphs. And then I did first experiments and was really flabbergasted. Like I could zoom, navigate, and he understood immediately the value of such a tool combined with the database, because now, even if one human expert with much expertise in one field wanted to pass what he found to the next, it got as simple as passing the link from the Grafana dashboard, and then at the PC of the other human expert, this dashboard was sending the exact same queries to InfluxDB, and the second human expert could go on exactly where the first started. And we saw something else. Maybe if we got it till a point where the customer himself could do the first part of the analysis, even the customer could get a bit of the work that currently was done by the human expert that had not enough time. And if the customer had done it, then he could actually pass the link and already, let's say, having done the first step of the analysis. So how to imagine that? From plots that were static and, yeah, well, you could obviously zoom, but only one time. As soon as you saved them as a graph, you had no possibility anymore. You moved into real dashboards. In our case, for example, our customers really appreciated introducing the concept of a moving average, because now they really could see trends easily. So in this case, you see a moving average and a range around. And spotting a pattern in a curve like that is much easier than spotting a curve in something like this, which simply looks like many, many data points, and well. Here you see the difference, like even here we have the former visualization. We could do the moving mean here as well, and it was very important to our human expert that this moving mean that he had now finally got used to, and that he found also a nice way of spotting trends, was transferred to Grafana. Influx already offered it. Then the second request was, now that we have a visualization that makes it possible to navigate not as only one person, but multiple persons or even the customer, couldn't we bring it to a multi-level dashboard thing? We could. Like we started with an overview. Oh, sorry. Is it that I can do something about it? Or? So let's wait. Invalid scan frequency. Maybe if I move the... No. Here on the screen, everything is still fine, so... You want to plug me out and in? No. Here it's there again. Yeah. So we're back. Thank you very much. Maybe is there a cable or something? Usually it's women and techniques, but okay, perfect. So what we see here is basically an overview level. We are going to see it in a bigger context later, where we see many servers of a single customer, and underneath we see the user experience, which I'm going to talk about immediately. Then we have this multi-measure level, where simply for each server, all maybe relevant measurements and metrics are shown in a certain way, and from there we can go to an even more detailed level where you can see the very single processor if you want. And the same thing for the user experience. The user experience is also shown in several ways. What is user experience? User experience is the next thing that they wanted me to get inside there, because they were telling me if the application is working well when you look at the metrics, but the users still complain, we haven't resolved anything. Because sometimes from the performance metrics, it might look that everything is going well, but then if you are behind a PC as a user and try to do something, maybe you encounter problems that are not one-to-one present in the metrics, or you simply cannot spot them. For this reason, they wanted to combine what we had done with the performance metrics with the user experience solution that we had already running, but it wrote data in a way that had nothing to do with InfluxDB. So it's called Alivix, and it's basically kind of a robot. So it's installed on a virtual machine. It's an agent, and our consultants or people from the company that is using it basically tell him what to do. For example, open up your business critical application, edit an invoice, search for a user, close again, and so on. Very simple stuff, but simple stuff that should really work all the time. Like as soon as this is getting slow, most probably all real customers are feeling that something is not working. So here you can see how it looked before, like we wrote it in a different way to a different database, and it was not appealing at all, but it still could be used to find periods of the day where maybe everything went slow. And now that we brought it into Influx and Grafana, we basically have 3 levels to look at the same data. Doesn't like me. It's too hot. We didn't monitor that proactively. If there's anything I can do, just let me know. Okay, perfect. If you have any questions so far, feel free to. maybe I simply tell you a bit about this Alivix. So basically, some of our customers also have more than one probes, for example, one for each level of the building, because they want to see whether the user experience is constant for the whole network or the whole building. Others maybe have probes for several seats of the company, like if a part is in Germany, the other in Poland, then they will see whether the user experience is the same for both of these countries. And yeah, it's looking great. And the three levels that we can see here is one that is maybe interesting for somebody who only wants to see whether the test is running or not. Let's say we are having holes where the test is not running, and we are having bars where the test is running, and the length of the bar is equivalent to the duration of the complete test. Then at the second level, we are doing kind of statistics and are seeing over time how the duration of several steps of the test is behaving, and we are marking with bars the character of those holes, so we know whether something has gone into timeout or something has not been executed. And in this level down here, basically each single transaction of the test is a dot. So why that? Because we are not using lines, it's nothing continuous, because all these values do not exist if the test case is not running. Like the duration of a transaction only exists if somebody, a human user or the robot, is actually performing this transaction. And we also have a related table. In this related table, for each event, we get further information. Like we know at that moment when the test actually was slowing down, which kind of AOS was used, which session ID was used, what was the host where the application was running on at the moment, and so on. The same annotations are inside here as well, but usually they are turned off because people prefer the tabular view of them. So bringing this kind of user experience together, how did we do it? Basically, here you can see the Alivix agent on the Windows VM, and here you see the agents. We are using mostly Telegraph for Windows or Linux to collect metrics. And then whenever a customer is not having this kind of solution on-premise, but as a software as a service solution, then we put NETEYE in the middle. And all this happens at the customer side, and then the NATS instances, like here the streaming server with the other, they communicate, and everything is arriving in our local Influx at our headquarters in Bolzano. And this is where we then start to have the dashboards, to do the analytics, and do kind of not only application performance monitoring anymore, but we can almost speak about IT operation analytics, because we are not interested in generating an alarm when the problem is already there anymore, but also about being proactive and anticipating stuff that might happen if we do not take a counteraction. This is a bigger screen of how it could look like in a very easy way. For example, here this customer has all his machines. Here, with a simple click on one of them, he is getting to the very detailed view of all the metrics available for that machine. Obviously, an SQL server will look completely different to a normal machine or a machine that has the application running on it. And here you can see the anomaly score, so what the machine learning algorithm has set in terms of the machine learning is at the moment analyzing server by server, but in a multivariate way on every server. So you can imagine that if I see that here for one server everything is getting a bit higher and a bit redder and so on, then not a single metric of that server, but maybe a constellation of metrics from that server actually is complaining or producing data that is far from the standard at the moment. Then we have this other batch task analysis. So here we are controlling whether there are batch tasks that are going in overdue, because at the moment there is no batch server available where they could be executed. And underneath, we have, for example, free probes of the ALEVIX with the user experience, and everything goes hand in hand. Basically, if I see here that for free probes, now everything is taking longer than usual, I could go into that time interval and have a look at all the servers, at the anomalies. So we see that even here, more or less the same time interval, something changed, and I'm very fast in getting there. And I would never, ever have reached that with the former tools that we used, not even with all the prints on the desks that we had. And for this reason, I know that our human expert is very, very happy about how it's solved now, because this way he can serve not a single customer, but he can do more than one. So basically now our data is accessible via InfluxDB query language. We can zoom, and we have no more printing, and are happy with that point of the solution. Obviously, one is never content, one will always wants to go on. And now, no, that's strange because I thought there was, yeah, okay, let's go to the next one. Perfect. So here, for example, is one of the differences that we realized when doing a moving mean with Influx. Usually, you always have this shift to the right, which is quite logical, because moving mean is nothing other than placing a window on the data, shifting it, and always doing the average of the window. So obviously, at the beginning, I will not have the complete window, and only when the complete window is there, then I will have a data point. So this shift, this whole, is completely reasonable for one that is used to data. But for a customer that maybe is not so familiar with data, seeing a hole or something, if he is choosing the parameters in a bad way, because obviously we gave him the possibility to select the largeness of the window, then he was like, oh my God, I do not have data for half an hour. So that was something that in Pandas could be handled in a very, very quick and easy way, because there, for example, with the moving mean, you can always select whether you put it at the end of the window, at the center, and can therefore shift the curve. So if the influx function moving mean would also permit the center, it would be really good for us, because then also if you have event data or annotations, they stay in the right place. Otherwise, if you select the window with a wide largeness, you risk that basically you even shift it away from your events and they make not that much sense anymore. Here is something that we have seen. We were not allowed to use capacitor, because when we started, capacitor was not yet at that stage that we could do everything that we wanted. Nowadays, it should be possible to do almost everything that we implemented as external scripts and cron jobs and so on. But well, when we started, for example, one of the things that our human expert and the customer wanted to see together was effect quantification, meaning that as soon as I see my processor here is at 40% compared to last week, is that simply the same because at that time every week we are having a cron job, or is it something that I should worry about? In this case, we have 20% more than last week. So having simply a graph underneath 2 years ago was almost impossible. Like with Influx, normal Influx, it was not possible, and with capacitor, it started to be possible, let's say. So this was one of the other points where we then said, all right, we still have stuff in the external Python scripts that works, so let's adopt them a bit longer. Even when you then want a mean that is not the mean of the week as one value, but kind of what would each hour of the week look on average, which you can do with capacitor. So you will be bothered by me later, because now I found out that you're the very person I need to ask for information. This is something else that they wanted. Let's go back to performance monitoring. So when we do performance monitoring, usually our customers are interested in very concrete questions like, does my business critical application run well? Was it right to invest in software and hardware? So they are using the ALEVIX combined with the performance metrics also to show now that I have bought all these new hard drives, essentially everything is going more smoothly or faster. They want data that shows that their investment was all right. Then did our performance change compared to the last month? Maybe something new has really been released and you want to compare whether user experience or the performance changed. Let's say it's nothing new that we register infrastructure metrics. It's nothing new about the batch data. Also the application-specific metrics, we have them for a long time now. What was possible thanks to InfluxDB combined with Grafana was the scope-oriented visualization and everything that came afterwards, like the possibility to really see the user experience together with the performance metrics, the anomaly detection. Then what we are working on at the moment, a lot for bigger customers, is showing how SQL databases grow, doing forecasting and prognosis on that, also showing maybe this is the most growing, but in real, like the indices are occupying more than your data. Because this is something that you find a lot, and in that cases, maybe there's still much room, but at the moment, one would need to do a bit of cleanup and basically make them smooth again. Then also, we are analyzing what SQL queries by which user are maybe causing problems, and you can see it very nicely. In the machine learning and deep learning, my summer project is now to relate the user experience and the performance metrics in a different way. I want to use the user experience as a label and do regression or classification of the performance metrics, and not of a single machine anymore, but of the complete system. We have already started for a few smaller customers. First results are very encouraging, but it's still work in progress. I think before August we will not see something published or really shown. And the forecasting, for the moment being, we are using it a lot with the SQL database growth, but it's also very relevant for other metrics. And unfortunately, not only the cold winters, but we need other models for more complex stuff. So this is how the zoom in can look like. For example, you start at this higher level, then select this period where something seems strange. When you go into more detail, you see there is really something strange, and it's also higher compared to last week. And for example, in that case, you can find out there was a long-running transaction that blew up the version store, and for one night, everything was at a high processor. If you want to know more about one of our IoT projects, I'm very, very quickly showing that we're also doing other stuff than performance monitoring. One of them is the German company BEEGY. They are currently trying to decentralize the energy management, to tell that private households actually get their own solar cells on their roof, and then a battery in the cellar, and basically they sign up for 10 years flat. Like, they know what they are going to pay for their energy consumption within the next 10 years. And what do they give in return? In return, the company can decide whether at that specific moment this household is saving into the battery, whether it is consuming the power that it is producing, or whether maybe at that moment it's better for them to put everything into the battery and to consume usual power that they need to buy. What for? Their vision is that as soon as all Germany is covered by this kind of, they might have energy at hand in moments where the normal energy is expensive, and they are really thinking that this kind is revolutioning the energy market. Given that we have the lead programmer of the project here, if you are interested in a topic like that, please talk to him. It's Benjamin Grober here. And then we have a really nice IoT project in South Tyrol. So here, as you can see, the vision is the South Tyrolean apple that basically is having all his plants on the field, and he does not know, do I need to give water to my plants today or not? And in South Tyrol, basically, water consumption is about 250 million cubic meters a year, and about 110 million of cubic meters is used for irrigation, so for giving water to plants. Apples, wine, so all the products that we like of South Tyrol. And now we want to save about 50 or even 80% of that water by getting irrigation intelligent. For that reason, they have already put some sensors inside here the rural regions, and we are getting, via LoRaWAN here with several gateways, data in real time of how hard it is for the plants at that very moment to get water out of the ground. And they want to put it that way that water is only given to the plants when they really need it, because this not only would save water, it also would improve the quality of the fruit. At the moment, it's looking like that, like we have only these prototype sensors, and we know basically this water potential, how it's behaving over time. We see that when rain falls, it goes down, or when they irrigate, it goes down. Obviously, it's not connected to the normal power system. A small battery lasts for 1 season or even 1.5. And at the moment, we are using also the geohashing, but only to localize the sensors. And we are getting open data from the region, which we then combine. So we see the temperature that they register and make openly available together with what the plants say. And by combining them, as a first step, we want to create dashboards that they really trust in. And the decision is still, like everybody can say, now it's proposed that you give water, all right, I give water. But if after a year they see that watering exactly when the computer is proposing it is actually something to do, then most probably they can simply say, okay, let it do the IoT, the SMARTLAND, the intelligence, artificial intelligence for me. And I have good products without needing to activate the water at 12 o'clock or 2 in the morning. Okay, I hope this was a quick overview. And if you have more specific questions concerning the SciPy stack, in August we will have the SciPy conference in Trento, so northern Italy. And there again, we will also talk about monitoring, because a student of mine is showing the first results of what I told you earlier there. Any questions? Also later, or yeah.
Do you still use Pandas alongside with your InfluxDB data frequently?
From time to time, yeah. For some kind of manipulations, it's simply that the algorithms are all done. So it's just scheduling a cron job and making Pandas do it. But only for very advanced stuff, because most of the manipulations, you can basically do them via query, at least when you get more and more into the query language. And now with Flux, I hope really everything will be possible to do. Perfect.
Great, thank you so much. Appreciate it.
Can I leave it
Yes,
here?
definitely take.
No, it's not mine.
No, yours, okay.